The first step in this experiment is to obtain your acetic acid. The acetic acid is stored in the stock vinegar bottle in the fume hood. To obtain the acetic acid, you're going to bring over a small beaker and measure out approximately 50 milliliters. This isn't a precise measurement. Beakers do not make precise measurements. What we're doing is just grabbing a small amount that we can bring back to our station to measure more precisely with a graduated cylinder. Cap the stock bottle and return to your station to make your precise measurement. Back at your lab bench, you're going to use a graduated cylinder to measure out precisely 20 milliliters of acetic acid. To make a precise measurement, pour the acetic acid from your beaker into a graduated cylinder while you're looking at the graduated cylinder at eye level. It's important that you get down at eye level so that you can measure the bottom of your meniscus to exactly 20 milliliters. Once you have 20 milliliters, transfer your acetic acid into a 250 milliliter Erlenmeyer flask. Next, we need to obtain our solid sodium bicarbonate. You're going to measure out your sodium bicarbonate at the scale using a spatula and 2 weighboats. We'll see why we need 2 weighboats in a second. The first thing you need to do when you're using a scale is zero the scale out. We're going to put the weighboat on the scale, but we don't want the mass of the weighboat to be included in our measurement, so we're going to push the 0 button again. Now the scale reads 0, and any solid that we add will be the mass that's visible on the scale screen. We are measuring a very small mass of sodium bicarbonate in this experiment, so I'm going to scoop out just a tiny bit onto the tip of my spatula and lightly shake it in order to get a small amount to shake off at a time so that I can get to exactly 0.1 gram. You'll be measuring different masses in this experiment because the sodium bicarbonate is our independent variable, so your mass might be different, but you're going to use the same strategy. Here I've gone a little bit over my target mass. That's okay. What I'm going to do is scoop a little bit of the extra out and put it into my second weighboat that I obtained. This way I can play around with the mass a little bit until I get it exact. What I'm not going to do is transfer the excess back into the stock bottle. We should never put excess back into the stock bottle because it could contaminate the entire supply. So instead I use the secondary weighboat, which now I can either discard into the waste or give to a lab mate who might need more of the material. You can see that despite the fact that I was trying to get 0.1 grams exactly, the scale reads 0.105. That's okay. It's not common to get the exact mass, and it's not necessary either. What we do instead is write down exactly what the scale reads, even if it's not exactly what we were targeting. So in my lab notebook, I'm going to write down 0.105 grams. You may even see the scale fluctuate a little bit. That last digit has some variability, and even just bumping the lab bench can cause that digit to fluctuate. That's okay. Write down the digit that it most commonly settles on. So for me, it settled on a 5. So in my lab notebook, I write down 0.105 as the mass of my sodium bicarbonate for this trial. Now I can take my solid back to my lab bench to use in the reaction. Back at your lab bench, you should have your solid sodium bicarbonate, your Erlenmeyer flask with acetic acid, and a gas-tight syringe. We will use the gas-tight syringe to trap and measure the volume of carbon dioxide gas that forms from this reaction. This special type of syringe is graduated, meaning that it has markings indicating the volume that is contained within the syringe. Here I'm using a 50 milliliter gas-tight syringe, but we will also have 20 milliliter and 10 milliliter syringes in the lab. The size that you will use will be dependent on what your mass of sodium bicarbonate assigned is, so you may not be using a 50 milliliter syringe, you might be using one of the smaller options. Your instructor will let you know which syringe to use. The rubber stopper at the end of your hose should fit securely within your Erlenmeyer flask to make a nice airtight seal. Check to make sure this fits securely before moving on. Next, check to make sure that the plunger in your syringe is able to slide freely without any resistance. It's important that the gas that's formed is able to push out the plunger, so there needs to be not any friction here. If you're feeling a little bit of friction, try pushing it in and out to loosen it up, or talk to your instructor if you're concerned. Before starting your reaction, make sure that the plunger on your syringe is fully pushed in. This way the syringe is empty and the volume that's red will only be the volume of CO2 that is formed from the reaction. To run this reaction, you're going to take the solid sodium bicarbonate, transfer it into your Erlenmeyer flask containing the acetic acid, and immediately cap the reaction with the rubber stopper at the end of your gas-tight syringe. Once capped, carefully swirl your reaction while being careful not to disturb the gas-tight syringe. It's very easy to accidentally jostle the plunger, so just make sure that you're letting that sit independently and not disrupting the syringe while you're shaking the reaction. As you shake the reaction, make a note of your observations. What do you see happening in the flask? It's important to make a note of observations as you're completing an experiment and filling out your lab notebook. These observations could be critical to your discussion and lab report later on. You'll notice that as you're shaking the reactants together, you're going to start seeing the plunger in your syringe come out a little bit as the syringe is being filled with carbon dioxide gas. Shaking the reaction here actually mixes together the sodium bicarbonate and acetic acid molecules so that they collide and are able to form carbon dioxide. This is part of kinetic molecular theory that you guys will talk about a bit in lecture. So it's important to shake this reaction to mix together those reactants until the reaction has gone to completion. At the end of the reaction, we no longer have sodium bicarbonate and acetic acid. We now have water in the reaction mixture, carbon dioxide gas, which is trapped in this syringe, and we also have sodium acetate, which is a soluble product of this reaction, meaning that it's dissolved in water, so we can't visibly see it, but it is there dissolved in the water. Our final step here is to record the volume of carbon dioxide gas that is formed from this reaction. So to do this, you're going to read your gas-tight syringe. Be careful reading these graduations. Make sure that you are recording the correct volume, as not all of the syringes are identical. After you record this volume, you're done with trial 1. You will run 3 total trials of this experiment with the same mass of sodium bicarbonate in order to make sure that your results are precise. It's always good scientific practice to repeat an experiment whenever possible, since this will give you more reliable data. To clean up trial 1, dump your waste into the waste container, clean out your glassware, and start fresh, repeating the steps that we've already completed. All chemical waste will always go into an appropriate waste container. Once you've completed all 3 trials of your experiment and disposed of your chemical waste appropriately, thoroughly wash your glassware in the lab sink. After washing, lightly dry your glassware. It doesn't need to be fully dry. You can use the same paper towel to dry multiple pieces of glassware, and then return your glassware to the appropriate drawer. Glassware should always be put back where you found it, not left on the lab bench or left on the drying rack.